How's it going, everybody? In this video, we're going to transition from the IGP redistribution variation of inter AS option C to leveraging the labeled unicast capability inside of the autonomous systems, not just between the ASBRs, to propagate the labeled unicast routes. And where the benefit for this comes into play is dramatic increase in the ability to do BGP traffic engineering on the provider side. Because when you do things with the IGP redistribution of the BGP learned routes, you're limited to whatever traffic engineering you can do with the IGP, which, for those of you that have been doing any type of routing for any length of time, you know is pretty limited. Especially if you need to get specific on a per prefix basis or something like that. Or, a subset of prefixes, unless you're doing some sort of aggregation. And even then, as most of you know, that can be still pretty painful. So IGP really doesn't give you that flexibility. So by transitioning to labeled unicast throughout the entire topology, it makes it a whole lot easier to work with. Now we're going to do this over an AS2, and the reason why we're going to do it is because we have two different types of PEs, iOS and XR, where if I was just to do it on iOS, you'd be kind of missing out. So what we're going to go do is we're going to stop the redistribution on the ASBRs of BGP routes into IGP, so turn off the ISIS redistribution, and then we're going to enable IPv4 labeled unicast connectivity from the ASBRs to route reflector 2, and then route reflector 2 to the PE routers. So the way this is going to work and look will look something like this. We will do connectivity, we'll do labeled unicast from the ASBRs to the route reflector, and from the route reflector down to the PE routers. Each PE router and the route reflector itself and the ASBRs technically don't need to do this. So we're going to propagate the /32 loopback of route reflector 2, the /32 loopback of CSR8, and the /32 loopback of XR16. That's going to allow us to propagate the appropriate information that we need in order to get the connectivity to the remote end and getting everything squared away. So we're actually going to break the connectivity here when we turn the redistribution off, but that's okay. The BGP peering, the VPN peering between route reflector 1 and route reflector 2 that's currently in process right here, this connectivity will go down. That's okay. We don't really need that to work right now because we're transitioning to a different mechanism inside of the SP and how that would come into play. So let's go ahead and dive into the config and actually take a look at what's going to end up happening. So I'm actually going to just keep the green on the topology as we go through this. So on CSR6, if we were to go to global config, router ISIS1, and type in no redistribution of BGP level 2, BGP 2 level 2, turn that off, and do the same thing on 12. We're going to go log in, go to global config, router ISIS1, no redistribute, or address family IPv4 unicast, no redistribute BGP2 level 2. Go ahead and commit that. Now that we have that done, if we go look at route reflector 2, or I'm sorry, if we look, let's look at CSR8 instead, because it's a little easier to look at the config. Show MPLS forwarding table. We're no longer going to have the one routes. So these guys right here, now it's no label. So that's a bad thing, because now we don't have a out label to figure out what we're going to apply to it. So that's a bad thing. So now what we're going to go do is on route reflector 2, considering he's the center of the universe for BGP inside of Autonomous System 2, we're going to go ahead and, as soon as I can log in, go to global config, router BGP2, and then we're going to turn on the address family IPv4 unicast address family, and I'm going to type in network of 2.0.0.20/32 so I can advertise my local network. But then I'm also going to go type in neighbor, and I'll type in 2.0.0.6. We'll type in address family IPv4 labeled unicast, and I'll type in route reflector client. And the same thing with 12. get through all that. Route reflector, address family, IPv4 labeled unicast, and then route reflector client. And then we'll do a quick show config, and I'll just basically take this information right here, and I'll hit the up arrow a few more times to get to router 8 and then router 16. So we'll go through all that. So I'm going to go ahead, I'm going to commit that config, and then I'll go to CSR6. So CSR6 sees that happen. So we're typing router BGP 2, and now the peering is back up. But if we, for example, we're not actually configuring that for CSR6 back to route reflector 2. So if we show BGP IPv4 unicast neighbors, and we look at what's being sent and received, it says MPLS, that's the neighbor, that's going to router 5. But if we were to look at neighbors and look at a specific neighbor and look at 2.0.0.20, for example, no such neighbor. So got to be careful when you look at that particular specific example. So show run section BGP, we are peering, we're not peering with IPv4 yet with him. So what we have to go do now is go to global config, and we're going to go type in router BGP 2 neighbor of underneath the address family IPv4 unicast. We're type in neighbor of 2.0.0.20 activate, and that's going to cause that peering to come up now. And then we're also going to type in the send label command, which is going to allow us to do the labeling that we were talking about. So that takes care of that. So we also need to remove all these route statements, right? So this network statement here needs to get removed. We'll also do 16 gets removed, and so does 20. Because the route reflectors and the PE routers are going to propagate their routing information individually. So now that we have that in play, we should be able to go back to route reflector 2 and jump out of global config and show BGP IPv4 labeled unicast summary, and I am learning 3 routes from 6, which is a good sign. If I pull this back, you'll see all that. We'll look at some of the different aspects of that as we're going along. So I know you probably notice that the next hop information is incorrect. So we'll take a look at well, let's go ahead and just fix it now since I've already mentioned it. So you need to set the next hop self to be CSR6. So I'll come up here, and I will say underneath this connection here, I'll type in next hop self. And do clear IP BGP star soft. So we go back to route reflector 2, hit the up arrow, and now it's 6 is now the new connection. So now we have the connection to route reflector 1 is back up. You'll notice that happened right away because now we have a path to that network now, which we didn't have before. So I'm going to go back to let's go to XR12 now, and we're going to go ahead and get him squared away. So we'll type in router BGP 2. We'll type in we already have a neighbor to the route reflector via VPN 4, so we'll type in neighbor of 2.0.0.20. We'll type in address family IPv4 labeled unicast, and we're going to go ahead and type in next hop self, and then we're going to go ahead and commit. That's all we need to do. So that will bounce the neighbor adjacency, and then it'll bring it back up. But just remember, when it comes to setting this stuff up, you'll need to go underneath the VPN 4 and VPN 6 address families and make sure that IPv4, so my mistake, that you allocate label all. So I'm going to go underneath this and type in, and let's look back at route reflector 2 real quick, and hit the up arrow, and now we're going to have diversity. So now we got 6 and 12 coming in. So the ASBR to the route reflector, everything's working in that particular manner. If we look at the show BGP IPv4 unicast labels, we are, and in this case here, we need to allocate label underneath the VPN 4 or IPv4. So I'll go to router BGP 2, and I'll type in address family IPv4 unicast and allocate label all. I'll go ahead and I'll commit, and that's for the local label. I'm going to commit that. Then the do show BGP IPv4 unicast labels, and now we're allocating labels locally, which is what we need to do. So then I'm going to go, I've got the ASBR is configured, which is good. I need to go back to 12, and I need to actually go underneath IPv4 unicast and type in no and pull out the route advertisements here. So I'm going to do this one. I'm going to do 16, and I'm going to do 20. And commit that, because I'm no longer propagating them from the ASBR. Now, the last step in this process is to go to the PE routers, go to global config, router BGP2, and type in address family IPv4 unicast, and type in neighbor of 2.0.0.20 and activate it. And then I need to send label. That's going to go ahead and cause the propagation to happen. So once the peering comes back online, which will take it a couple seconds, do show BGP IPv4 unicast. I'm learning the routes from 1.2 and 101, and if I do the label value here, I'm also setting up label values. So I have outbound labels, which is what I expect to see. Now let's go jump over to XR16 and get him squared away. Go to global config, go to global, router BGP2, we'll type in neighbor of address family IPv4 unicast, and then we're going to type in allocate label all, and I'm also going to type in network of 2.0.0.16/32, and let me do that on CSR8 as well. Network of 2.0.0.8 mask/32, so the propagation happens. On 16, we're going to exit out of here and type in neighbor of 2.0.0.20, address family IPv4 labeled unicast. I'm going to go ahead and set the next hop self to be that for connections, or no, sorry, next hop self is not necessary here. I should be able to just type in the commit there, and then that should be all that's necessary. So I'll commit that, then I'll form a connection to 20 again. Now if I look at CSR8, if we look at do show IPBGP, we're going to learn 1 and we should see 2. So that means CSR1 should also see show IP route. We should see 2 and 8. 8 is there, 20 is there, which is fine. Eventually 16 will be there as well. And there's 16 now. So 16 is there. So that means we should also have MPLS labels there for it too. So show MPLS forwarding table. We should see 20, 16, and 8 respectively in LDP, which we do. So that means AS1 is still doing IGP redistribution of BGP learned routes. So BGP to IGP redistribution. So AS1 is still going to allocate labels for all of the neighbor connectivity on AS2. But AS2 has now transitioned over to labeled unicast and is doing things that way. So now we should need to test the end-to-end connectivity. So we're going to go back to router 19 and do a show IP route. And I should have the connections in here, which I do. So I'm going to do a trace route to 10.1.25.25, sourcing from loopback 1 numerically. And I can get there all day long. So my end-to-end connectivity is there. Now let's reverse the process and go from router 25 to router 19. Show IP route. Let's do a trace route to 10.1.19.19, sourcing from loopback 1 numerically. You'll notice that we have some additional labels here. And these additional labels are going to be BGP labels that we're going to be using to get to the ASBR and so on and so forth. So, but that's basically the configuration as it sits right there. So now that you've seen both sides, we're going to transition the other AS1. We'll flip this one over to labeled unicast as well, so we have it on both sides. And then what I'm going to go do is, in the following video, I'll walk through a deep dive of the why there's additional labels and where they come into play and how that all type of stuff works. Instead of trying to pack it all into one video, I'm going to take my time and walk through why we have a 3 label stack here and stuff like that versus a 2 label stack that you guys are probably familiar with. So let's go ahead and convert the other guys here. So on CSR5, we're going to go to global config, router OSPF 1, no redistribute BGP 1 subnets. And on XR11, same thing. Router OSPF 1, no redistribute BGP 1, commit. And then on route reflector 1, we're going to come in here and go to global config, router BGP 1. We're going to type in address family IPv4 unicast, and then neighbor of 1.0.0.5, activate, route reflector client, and then we'll do 11, activate, and then we'll do 1, activate, and then 2, activate, and then do show run section BGP. So coming down here, we also need to do the send label. So we'll come in here and do a send label. So it's a peer group. So we'll type in the peer group that we need to apply is this guy right here, neighbor peer group, and then we'll type in here send label underneath the IPv4 unicast address family, and that'll apply to that, and then route reflector client. So that'll apply to everybody. So now do show run section BGP. That's been applied to everybody. So now if I do show IPBGP, the other connections aren't going to be propagated yet because of they're not configured to peer with CSR1 yet, or the route reflector, I should say. So what we're going to go do is on router 5, for example, I'll come in here and type in router BGP1, and then I'll type in address family IPv4 unicast and neighbor of 1.0.0.101, activate. And then I will then take the send label. So we're doing labeled unicast here as well. And then I'm also going to do the next top self because we need that anyway. So we have that in play. I'm going to do the same thing for XR11. And since we're on the process of doing this anyway, so router BGP1, type in neighbor of 1.0.0.101, address family IPv4 labeled unicast. We're going to go ahead and set the next top self. That's really all we need to do at this point. And commit. So that'll allow that connectivity to happen. And then we're going to go to router 1 and go to global config, router BGP1, address family IPv4 unicast, neighbor of 1.0.0.101, activate, send label, and then do show history. We'll just take these few lines of config and dump it onto CSR2, and this will speed the process of convergence up. Just like that. So now that we have that in play, when I go back to route reflector 1, for example, and I do show IPBGP, I'm going to see a bunch of routes coming in, and I see stuff coming from for CSR 8, 16, and 20, respectively. And then if I hit the up arrow and do unicast labels, let's do show BGP IPv4 unicast labels. We have labels associated, which is great. Now on CSR5, what I have to go do is I have to do show run section BGP, and I'm still advertising these loopbacks. So I'm going to type in no and pull these network commands out. And 101. And then I have to go locally on each one of those networks. So let's go underneath here and do show run router BGP. And I have to remove these network commands. So address family IPv4 Unicast, and pull these network statements out. 2 and then 101. Commit that. And then I go back to route reflector 1 and I go to network of 1.0.0.101 mask /32. I go to router 1, same thing, network of 1.0.0.1 mask /32. And then 2, same thing. Whoops. Bring CSR2 way on back over here. And network of 1.0.0.2 mask /32. So now that I've done that, if I go back to CSR8 and I do a show BGP IPv4 Unicast, I should have those routes in the routing table, which I do. If I do labels, there will be labels associated to that, which is exactly what I'm looking to have. Now, if we go back to router 19 and we do that same trace route again, but we hit the up arrow, you'll notice that we have a 3-label stack going from our internal connection over to the other side, right? And if we go 25 to 19, we have a 3-label stack. But it's 3-label stack inside of our AS, not a 3-label stack over here. And that's working all day long. So we have end-to-end connectivity everywhere we go, which is really, really good. So if we were to go back to like CSR1 and look at the show BG or show MPLS forwarding table, where we shouldn't have any MPLS or IGP learned routes from the 2 network. We only have 1 nets, which is what we're looking for. So this is basically how that would tie into play. So this gives us traffic engineering options now. So if I was to look at this from the show BGP, VPN, v4, Unicast, all, I'm looking at this from the perspective of I have lots of options here. And if I wanted to do any traffic engineering, I could. But I'd have to do them on the ASBR to affect how the traffic is going to get forwarded. Because it's a little kludgy now, because now we're changing the operations. It's, we're exchanging enough routing information that we know who the remote PE is that we're trying to connect to. And that's going to be based off the next hop, right? So if we were to look at this from the perspective of, look at, for example, RD 2:2, and specifically look at the route to CSR or router 26. My next hop is, I'm receiving this update from 101, right? So if we were to do that trace route again from, let's look at router 20, show IP route, and do a trace route to 10.2.26.26, sourcing from loopback 2 numerically. We are flowing through CSR5 and CSR6. But if we wanted to alter this and make it go through XR11, we would go to XR11 and we would type in, let's create a new RPL. We'll type in a route-policy. We'll call this RPL option C, local preference, and we'll set the local preference to be 200 and then exit out. And then we'll do a router BGP 1. I'll type in neighbor of 12.11.12.12, address family IPv4 labeled Unicast, and we'll type in route-policy, and then the RPL will be inbound, and we'll go ahead and commit that. Let's actually not commit. Let me adjust that real quick. I still need to, but no, because if I look at do show run RPL, the option A local preference has a pass, and this one does not at the moment. So let me do this real quick. route dash policy of RPL option C, and so we'll also set the local preference to be 200 and pass. So let me go ahead and commit all that. Do show run router BGP, and so now underneath this connection to 12, we have this guy applied, which means do show BGP IPv4 unicast. We're seeing 200 being applied. We go to router 1 and hit the up arrow. We see that we may need to clear, or sorry, show BGP IPv4 unicast. Now we see 200 being propagated. So that means that when we do our trace route from 20 to 26, we should go through XR11, which we are. So it's not the VPN-B4 address family that you need to be paying attention to. It's you're using BGP through IPv4 connectivity to do the labeling. That's what's going to get you from your ingress PE router to your egress ASBR. So it's IPv4 unicast that you're modifying. So if you look at it from CSR1's perspective of VPN-B4, you're like, well, I'm getting this information and it's the local preference hasn't changed. But that's how you get to CSR8. And there's that's being propagated to its route reflector, and there's appearing to our route reflector, which is providing us the update. We saw that when we looked at this information right here. We can see that our route reflector is who is passing us the information. So we can't look at that. We have to look at the IPv4 aspect of it. And when we look at that, we go, oh, well, the local preference is pushing us here. So that's one of those key capabilities that if you don't pay attention to it, or we'll say the next hop is incorrect or not set up correctly, this can be detrimental if you're deploying this type of a scenario. I troubleshot this for long times, many hours, trying to figure out why the traffic wasn't going the way it was supposed to go. And this can be tricky. So you're not modifying a VPN-B4, you're modifying IPv4 so that you can adjust how the ingress PE to egress ASBR connectivity is coming into play. The VPN-B4 is how the label extensions are coming into play, and we're going to talk about how the labeling applies in the next video. So until next time, guys, thanks so much for stopping by and hanging out with me in this video, and we'll catch you guys in the next one.